Hey, welcome to Geometry, Lesson 1.4, talking about angle measure with this lesson. Here is our new terminology. Make sure you know these terms by the time we're done with this lesson, and if you're one of my students, use those extra examples in your book. Let's get started. It says, first of all, a ray is what should go in this first blank. A ray has one endpoint, and maybe you saw this over here. It extends infinitely in one direction. All right. Depending on how old this video is by the time you're watching this, maybe you don't even know who this is, what band this is, but this is going to be a boy band video in honor of the boy bands out there. Ladies, you may be crazy about One Direction. Maybe they're too old for you now. I don't know. But let's pretend one of the guys' names in this band is Ray, and he's part of One Direction. That'll help you remember that a ray extends infinitely in one direction. This is not my greatest picture, but this is an arrowhead. I'm calling this point A, this point B. This is an example of a ray. This is ray AB. Or you could also say AB with a little ray symbol above it like that. Saying ray AB is the same thing as saying AB with the ray symbol above it. However, in previous things with segments, we could switch the order of the letters. Lines, we could switch to the order of the letters because it meant the same thing. Here, however, it doesn't. Ray AB starts at A and goes through B. So this is not the same as ray BA. So make sure you make a note of that. BA, ray BA would start at B and go through A in the opposite direction. So that would be a different figure. The next blank should say opposite rays start at the same endpoint. So they start at the same spot, the same endpoint, and go in exact opposite directions. And together they form a straight line. So let's see an example of that. I'm doing this freehand. I'm going to use my straight edge on this one, or my straight line tool. Let's make that blue instead. There we go. All right. So on that, I've got together opposite rays forming a straight line. So this is just going to look like a straight line, but it's actually two opposite rays in disguise. Say this is point A, this is point B, and this I'm going to say is point C. And so two opposite rays in this picture would both start at B. They would start at the same endpoint and go in exact opposite directions. So BC and BA, those two rays would be opposite rays. That would be an example of a pair of opposite rays. So ray BA and ray BC are opposite rays. And then finally for this slide, we've got an angle is formed by two non-collinear rays that have a common endpoint. So an angle formed by two non-collinear rays that have a common endpoint. The rays are called the sides of the angle, and the common endpoint is called the vertex. So let's see a picture of an example of an angle. So on this one, I'll draw in something that looks like this. Here's an example of an angle. And I'm going to put some labels on here. This point I will call point B. You can put a point right here. You don't have to, though, if that's clearly where those two rays would intersect. We know that where they come together would be point B. This is point A, I'm going to call it, and over here I'm going to call this point C. So what's going on here? This is an angle. Why this is an angle? Because it has what I said it had to have over here. It's got two non-collinear rays that have a common endpoint. Their common endpoint is B, and they both emanate, the rays both emanate, shoot out of that common endpoint. And the sides are going to be these two rays. The vertex will be point B. So this is angle, one way to say this is angle ABC. you connect the dots and it needs to actually form the angle. So I'm going to get out a little highlighter here just to show what I mean by that. So if I connect A to B to C, do you see how it forms that angle right there? If I connect C to B to A, it still forms the same angle. So both of those are valid ways to say this angle. So you could say angle ABC, or you could say angle CBA. Just connect the dots, and if they make the correct angle, then you know that's the angle you're looking for. The sides are the two rays that make up the angle, so BA, ray BA, and ray BC. And finally, the vertex in this picture, that's that common endpoint, that is point B. So let's check out an example where we use what we just learned and put it to practice here in this example. And all angles with Y as a vertex. So here's Y right here. It looks like I have some different options. I've got angle 1 is how this is labeled, so that's one possibility, one way to say that particular angle. You could also say SYN. That would describe or make the same angle as angle 1. So I'm going to say angle 1, and then this is an equivalent way to say the same angle. So equivalently, you could say or angle SYN or angle NYS. Those are all the same angle. It's just different ways to say the same angle. Angle 2 also has a vertex at Y. So that's the same, not the same angle, that's another angle that has a vertex at Y, different than angle 1. So angle 2, or you could say NYC, what's up New York City? Or you could say CYN, angle CYN. You need to put the angle symbol in front of the three letters, otherwise it means something different that we'll learn about later. And then some of you may have a book, if you're not one of my students, that talks about zero angles and straight angles. A straight angle here would be SYC. Our book, if you're one of my students, doesn't talk about that. So our book, that's why it says these non-collinear rays. But you should know that a zero angle, some books would say that would be two rays on top of each other. So there's no angle measurement. And a straight angle, 180 degrees, would be SYC or CYS. So I'm not going to write that down, but if you're watching this and you're not one of my students, just know that that is the case. So the sides of angle New York City, what sides does that angle have? That would be, start at Y, that's the endpoint, the common endpoint, the vertex, and go through N. You could say that, and the other side of New York City is YC. So we have segment Y, or not segment, ray, YC. A pair of opposite rays. It looks like I've got one straight line in this picture, so it's got to be using that straight line, starting at Y and going in opposite directions. So it looks like YS and YC are opposite rays. A point on the interior of angle 2, that looks like it would be point X right there. And that's the only one. If you don't know what the interior of, we haven't talked about that, but it's, get orange instead, it's stuff that would be on the inside of that angle. And if that angle extended infinitely out in all directions. So if it went that way and that way, it would continue going this way. So X is the only one that's on the inside or the interior of that angle. So that's the only thing I could write there. A point on the exterior of SYN, here's SYN. So now we're talking about, I'm going to extend the orange idea out. You don't have to color this like this. I probably wouldn't do that if I were you. But all the orange stuff now is on the exterior of SYN. So point A is on the interior, but all these other points, B, Z, C, and X, those are all possible answers for this one. So you could say B. Get back to my blue. You could say B, or you could have Z, C, or X. All four of those points would work. Now, some classifications of angles. What are some different types of angles? You've probably learned this before. Probably learned this in, I think, maybe even elementary school at the first time you would have learned this. So a right angle, an acute angle, and an obtuse angle. Oh, if you didn't catch that reference, here was Sync. So this is a boy band from modern times, more modern times. In Sync, oh yeah, back when I grew up in the 90s, and now way back in the late 70s, early 80s is when they were most popular. Menudo, paying homage to those boy bands out there. It all started with One Direction, because I had to say that with the Ray. Anyway, a right angle. What makes a right angle a right angle? Well, we can put this in the corner. Good time to color code here. This just means, this symbol, if you see a little box in the corner of an angle like that, that means 90 degrees. So this symbol means 90 degrees right there. Not 98 degrees, another boy band from the 90s. Oh boy, Mr. Wagner, why are you talking about this? I'm just trying to keep it interesting, okay? Measure of angle A equals 90 degrees in this picture. All right. Acute. What makes an acute angle acute? Oh, it's so cute. It's little. Yeah, that's kind of how I think about it. It's less than 90. So if you have a different color, good time to color code some things here. Don't draw this in, I would say, unless you actually have a different color. So notice that would be a right angle, and this is less than a right angle. So what makes an acute angle acute? It has to be between 0 and 90 degrees. Notice the less than symbol is different than the angle symbol. I haven't talked about that yet, but the angle symbol, you have a horizontal portion on the bottom, and this goes up at about 45 degrees. This is more like 30 degrees down this way and this way, so you have no horizontal part there. So try to make that clear when you're drawing in the angle symbol versus the less than symbol. And then finally, an obtuse angle. What makes an obtuse angle obtuse? Well, again, good time to color code. This would be 90 degrees. We're saying something that's bigger than 90, more than 90 degrees. So we have 90, but you can't get bigger than 180. So we have, you can't get 180 or bigger, I would say would be a better way to say that. 180 degrees, again, some books call that a straight angle. 0 degrees, some books would call that a zero angle. Now we're going to measure each angle and classify it as right, acute, or obtuse. So I'm going to actually get my protractor out. You ready for this? Boom, there it is. All right. So go get a protractor, pause the video if you need to. Make sure you're practicing this right now. So we're going to measure each angle and classify it as right, acute, or obtuse. This one, I have a box in the corner already for angle MED. If I connect those points, there's the angle that it makes. And so I don't even need to bother measuring this because I'm told in the picture what it is. I know it's 90 degrees. And because it's 90 degrees, that makes it, right up here, a right angle. So this is going to be 90 and right. Now what makes something acute or obtuse? Now we're going to have to think about that. So 0 to 90, 90 to 180. I need to take my protractor here, rotate it around. Let's see how I do that again. There we go. So I'm going to spin it around, and I'm going to move this so that this crosshair point right here, where these come together, that needs to be on the vertex of the angle I'm trying to measure. And DEU, which is here to here to here, that's the angle I'm trying to measure. So I'm going to move this so that the crosshairs of that are exactly on that point right there. And if I were to extend this out a little ways, it looks like it would come right to about there. I didn't even know I could do that. Shrink down protractor, there you go. So it's coming to right about there, and it looks like that's, I would say, either 52 or 53 degrees based on what I can see there. Now you might have a protractor like this one where it has two measurements, and don't get confused by that. Think about whether it's bigger than 90 or less than 90. If it's bigger than 90, use the bigger number. If it's less than 90, use the smaller number. So it's starting at 0 and going through, and I am not doing a good job with this, am I? So rather than just throughout this whole video, I've been doing a good job, I think, before that. I can adjust what I was saying there. What else did I forget to do? Yeah, I got to rotate this around so that one of the sides actually lines up with what I'm trying to measure. So I'm trying to measure this angle, DEU, right here. Before I was measuring MEU, and that's not what I wanted to do. I wanted to measure DEU. So this is better. Now if I extend this out, or with mine, since I have this fancy little option, I can just shrink the protractor. So notice this vertex right on the angle, one of the lines is lined up right with the side there, and then the other one is what I'm using to measure. This is clearly less than 90, so I'm using the smaller number here. Looking at that, it looks like it's close to either 37 or 38. So I'm going to go with 37, and because that's less than 90, that would be acute. And finally, MEO. So this one, now I can rotate this back around, and I can line that up. Now I still have that on the vertex right there. I've got M lined up here. I've got this side lined up with one of the sides of the angle. So MEO, and I'm now measuring over to here. So MEO, it looks like that one. If I look at that mark right there, that's about 152. Again, this is bigger than 90, so I'm going to look at the bigger number on here, not the smaller number. I'm going to use the bigger number here. This is about 152 degrees, and that is obtuse since it falls in the 90 to 180 range. And I think I can get rid of this now. So notice here on this question, I said measure each angle. If it doesn't say to measure the angle, then you can't use a protractor. You have to use information in the picture to figure out what it is. So a little summary of all the symbolism we've been talking about in these last 4 lessons. This is going to be, I think, a very valuable thing to have in your notes. We've learned about segments, we've learned about rays now, we've learned about lines, and we've learned about distance. And so a picture or a description, I'm going to draw now basically congruent segments here to start, except for this one, but then I'm going to put arrowheads and points on these a little differently. So I'm going to say this is segment A, B. This one I'm going to say is ray A, B, and this continues in this direction, going on and on and on. And then I'm still going to use these 2 endpoints, but a line goes on forever in both directions. I think I'm going to start a band called 2 Directions instead of 1 Direction. Oh, I cracked myself up. All right, and the length of a segment. This would be more of a description on this one in the picture. So the length of a segment, that's the distance. And then in symbols, remember we can say AB. Move this a little to the left here. Segment AB, or you can say segment BA. Both of those work in this case because they describe the same figure. It doesn't matter if you start at A and go to B, or start at B and go to A. It's still the same segment. Ray AB, remember, is not the same as ray BA. So this one I would have to say A and then B, and not B and then A. And then I have my little ray symbol above there. And then line AB, or just as well line BA. And finally, for the distance, you just write the points. You just write AB or BA with nothing above it. So a quick little recap of things we've learned so far, starting from 1.1. Some very important things to remember. Angles with the same measure are called congruent angles, just like segments with the same measure are called congruent segments. A ray that divides an angle into 2 congruent angles is called an, well, it's got to start with a vowel, right? It's an instead of a. An angle bisector. So you said that, nicely done. Just like a segment divided into two equal parts. Whatever that was that divided it was called a segment bisector. Same thing works with angles, but it has to be a ray cutting that angle in half. And the same number of arc marks, and we'll see an example of that in our final example. Arc marks on angles indicate that those angles are congruent. So let's finish up with this. And we've been talking about boy bands in this lesson. Here's a man band right there, one of my favorites, Red. If you haven't heard of them, I'd say go check them out. They're really good. One of my favorite bands ever. So example 3, suppose that ray AD, I'm going to use a different color here to show you something real quick. Remember, you can say this. Instead of writing the word ray, you can just say AD with that if you wanted to. So a quick reminder of that. Is an angle bisector of angle BAN. Same thing works with this. If you want to write out the word angle and then BAN, that works. Or you can say, put the angle symbol and write BAN. So it doesn't really matter, but I think you're going to like using the symbol rather than writing the word angle more often than not. So this is determined, if you have a little m in front, that means the measure of whatever angle you're talking about. We don't just say angle BAD equals something, we say the measure of the angle equals something. So we're going to have angle bisectors here. If this is true, that means, here's my arc mark thing that I was talking about, this and this angle would be congruent to each other. These have the same number of arc marks, 1 and 1. So that means this is congruent to this. That would mean that the measure of angle BAD would have to equal the measure of angle DAN. Bad Dan. So we have, I can replace now 13x minus 3 in place of measure of angle BAD. And I can replace measure of angle DAN with what it equals, 20x minus 17. And from there, now it's algebra time. So I'm going to get the x's on one side. Looks like subtracting 13x would be the easiest way to do that. That would keep things positive, and that means the x's would cancel here. If I move the 17 over there, that would get the integers, the regular numbers, on the other side. And so I have 14 equals 7x. The rest canceled out. From there, divide by 7, and you've got 2 equals x. Some of you might box that in and say, I'm done. Final answer. Hold on. It says determine the measure of angle BAD. So we got something very important. Now I need to plug that in. So I can use, I'm going to go with this symbol again. Remember, a little equilateral triangle, just the dots means therefore. If you want to use that, feel free. So therefore, the measure of angle BAD equals 13x minus 3 becomes 13 times 2 minus 3. 13 times 2, that's 26. 26 minus 3 is 23. Final answer is 23 degrees. To check if and see if that's right, it would be very easy to plug in 2 here for x as well. 20 times 2 would be 40. 40 minus 17 would be 23. And should that be the same? Should this be 23 and this be 23? Sure. And that reminds me to mention one more thing here. Did this look like a 23 degree angle? Absolutely not. Does this look like a 23 degree angle? Absolutely not. This looks like together would be way more than 46. That's what you'd get if you'd add 23 and 23. That's why it's important to not trust the way the picture looks in geometry. You have to trust the information in the picture. So regardless of what it looks like, based on the information, I'm saying this angle has a 23 degree measurement. So I purposely made it a bit bigger like that to make that point clear. All right, so go back and review if you need to. We've got all these terms now that you should understand. If you don't understand what these mean or what they are, go back and review the video. Ask me questions in class if you're one of my students. Comment on the video. As always, let me know if you see anything that needs to be fixed in the video. I'll do my best to do that. Hope you have a great day, and I'll see you later for lesson 1.5.